In this video, you'll see how to connect two HC-05 Bluetooth modules to communicate with each other. Getting two Bluetooth modules to work together and communicate is a lot trickier than getting a Bluetooth module to work with a phone. When you go online and try and investigate how to do this for yourself, you'll find that the websites and forums, they give different advice and different instructions and different steps, different orders, and I suspect part of the reason for that is because there's many manufacturers of Bluetooth modules and there are many types of Bluetooth modules, and so it can get very confusing. So to make my life easier, I've stuck to one brand. I'm using the Aokin HC-05 Bluetooth module, which I bought from AliExpress, and this video is done in October 2019, so it cost me about $2.87 US each, and so I've got these working, and that's what this video is all about. So this is the basic setup. I'm using this for testing purposes, for discovering how to use Bluetooth, but also this can be used for my final implementation into my own wireless devices. So what I have here is on the right hand side is my HC-05 acting as a master, and that's connected to its own Arduino board. And on the left hand side I've got another HC-05 acting as a slave connected to this Arduino board. Now with this arrangement I can have each slave communicating with only one master, but I can have a master that can communicate with many slaves. So in terms of implementation, I can use this particular arrangement here to be my transmitter for a remote control, and this could be a receiver on a remote control device. And I can have many different remote control devices. Each can communicate to one remote control over here. So for this demonstration video, I have the serial monitor outputs here for my transmitter sketch and my receiver sketch. And what's happening is my transmitter is sending out an oscillating value of 1 or 0, and the receiver is receiving that value and displaying to the serial monitor. Now to get this how-to working, we're going to do this in a few steps. First of all, we'll get it wired up, and then we'll configure the Bluetooth modules, and then finally upload the sketches. Okay, and let's get the wiring sorted out. So here we have a wiring diagram showing what to do, and this wiring diagram will be available at the end of the video. So there's my unit board, there's my HC-05, and as you can see I've marked on it an S there for slave. And I've done the same thing for the other module, M for master, because it's so easy to get mixed up. Let's get rid of this. Okay, and let's start wiring this up. So normally when I do this kind of thing, I always connect the red positive first, but actually I'll leave that till last, because when you want to get this going and configuring the module with the instructions, you actually connect the red last. So I'll do instead the negative or ground. So you can see here we've got ground there. So ground goes there. Okay, and I'll connect that to ground on the Arduino board. So we've got 3 grounds, so any one will do. I'll choose this one. There, ground. Now I will connect the receiver into Arduino to the transmitter on the HC-05. Okay, so for my code, I'm using for my receiver pin number 2, which is this one over here. And I'll connect that to my TX on the module. there, TX. Now let's connect the receiver on the module to Arduino's transmitter. Now there's two ways of doing this. If you're just doing testing and will get things done quickly, just do it this way. So there's my transmitter on the Arduino board, which is I've set to pin 3 based on my code. So put that in here, 3, and then that goes to my receiver on the module. Now there's a slight problem with that because Arduino outputs 5 volts power as well as 5 volts logic. Okay, now the module here has a 3.3 volt logic. So if you're trying to send information, it should really be 3.3 volts, not 5 volts. And the risk is if you give it too much voltage for too long, you can damage the module. So for the short time, I've gotten away with it, and fortunately had no trouble. But in the long term, for your permanent installations, you should have a voltage divider. Okay, and all you do is basically have this end here, 1000 ohms, and this end here, 2000 ohms, and by doing so, you reduce the voltage going to your receiver. And that's shown here on the diagram. We've got 5 volts coming out here, and because of the resistors, I end up with 3.3 volts going to my module, and the other voltage going back to ground, and that way we can control the voltage. So as I said, for testing purposes and just trying to get this thing working, it's okay for the short term, but the long term, make sure you have a voltage divider. And now for the last connection, we're going to have 5 volts from the Arduino board, which is here, going to my 5 volt input on the module, which is here. So there it is, the circuit without the voltage divider for quick testing and configuring, but for the long term, the circuit with the voltage divider installed. So all you have there is just a little bit more complicated with 3 more resistors. Now let's connect the board to the PC. And we'll see that the module is in trying to pair mode, but it can't pair with anything because there's nothing to pair with at the moment. Alright, so now we've got that situation there. We need to find the code, which is in this file here. Bluetooth AT mode. Double click on that and you'll get this. So in the code here it has all the instructions step by step with an explanation of the AT commands and how to configure the slave and the master Bluetooth module so that they can communicate with each other. So in Arduino's RDU, go to Tools and make sure it's the right board, Arduino Uno, and check the port. In this case it's going to be for me port COM11, and then to make sure it can communicate with the Arduino board, I will go down to get board info, and if we see the pop-up we know we can communicate with the Arduino board. So the next step is to then compile and upload the file to the board. So I'm compiling now, done, and now upload, and it's uploaded. So now we have that point there. The next step is rather peculiar. So what I'm going to do is I'm going to disconnect the power to the Bluetooth device by pulling out the red VCC 5 volt lead. And now you will see the button here. That button is for switching into AT mode. Now to make that work, I need to keep my finger pressed on the button as I insert the red lead back in. So here I go, the button, keeping my finger pressed down, and reinsert the power lead. And there it is. And now you see that the LED is blinking slowly. I estimate that's a 2-second on blink, 2-second off blink, thereabouts. And that means the Bluetooth device is now ready for AT mode. Now this is the AT mode, and that's what we need to configure the device for this one to act like a master and the other one to act like a slave. So the next step is to open up the serial monitor, which is easily done by clicking on that funny symbol there. And here it is, and you can see it can detect the Bluetooth device, but it's not working quite well. So it's very important that the next two steps are done properly. At the moment my code is set to display to the serial monitor at 9600 baud, so I need to change that to 9600 baud, and make sure that this also is set to both NL and CR. And we're going to see that it shows a response, so therefore it looks like we are almost there to communicate with the Bluetooth module. So to test it, I need to type in characters in uppercase, and I'll type in AT. Now if it doesn't have to work once, try again. And there it is. So it can detect my Bluetooth device, and I can communicate with it. So let's find out what its name is. And to input queries, we complete each instruction with a question mark. Here it goes. And the name of this device is H-C-2010-06-01. Now we can change the name by typing in another command like this. And we can check and verify that it's worked by retyping in the query, the question mark, and there it is. It's now changed to HC-05M. So this is my master module, so I need to configure it to be act like my master. So therefore I'm going to change its role. Let me query the role right now. It's role number 1. So role number 1 is correct. It's set for being a master. By default, when you get an HC-05 module brand new, they have the default role of 0, which means slave. So you need to change that, but I've set mine already. We also need to make sure that the password is compatible with the slave module. So I'll check the password. And by default, your typical Bluetooth module has the default password of 1234 or 0000. I won't change that. Next thing, I'll check the speed settings for communication by typing this command here, and I'll keep it at that value there. To change that value, I'll basically type in AT plus UART equals whatever baud rate I want, comma, whatever stop bit I want, and comma, whatever parity bit I want. But these defaults are fine. Now I will check the mode for communication, and because this is my master, I want it to communicate with many different receivers, many different Bluetooth slave modules. So I want the mode to be available to communicate with any of these devices. So therefore I will query the status, and the mode is 1, which means connect to any. Now it's very important though for your slave devices that the C mode is set to 0. That means we'll only connect to the master, one master, that's it. Now everything's ready to go there, apart from 2 more things. I want to bind this to my slave module, which means I'm telling my master that the address I'm going to give to my master is a valid authenticated slave that I want it to communicate with. So to find out what I have at the moment it's configured to communicate with the slave module FCA8-9A49C3. Now if I want to change that to another module or add another one, I go like this: AT plus bind. So this is the address of my slave module or another slave module, and the syntax is very important. It has to be following 4 characters at the beginning, followed by a comma, not a colon, 2 more characters, followed by up to 6 characters here. So that is a syntax, you gotta follow that. So if you have a, for instance down here, if I have the last 4 characters there, after that colon is 49C3, just say I want to communicate with 49C3, I basically type in 0049C3, right? And I'll get everything else done correctly so it makes sense, and you'll see that it'll work fine. FCA8 9A and so on. So there it is. And notice how I'm not using colons like down here. That's a normal notation, but for changing things you separate each of those set of numbers with a comma, not a colon. And let's try that now. And it says OK. Good. The last thing to do is very important. So the bind command basically tells the module I want it to recognize the other module and connect to it, but to actually pair, you're going to type in this command too, at plus pair, right? And it has 2 parameters. First, the address of the slave module, comma, then the wait time to try and connect. So type in the same address as before, FCA8, comma, not colon, 9A, comma, 0049C3, and now I type in a wait time, a timeout time, and let's say make it 10 seconds. And press enter. And down here it says yes, okay, I will pair with that module when it becomes available. Alright, so this is now complete. Now here's my slave module. I'll connect that up to the PC as well and configure this one. You'll see that the light flashes, which means it's trying to pair. And now for the slave module, the same thing again. Tools, make sure it's the Uno in my case, port number, this one, then get board info to check. Yes, all good. And now we compile and upload. Good. Now upload. Great. So that code is now uploaded, but now we need to change this into AT mode. So I put out the power cord again, the red one there, the 5 volt. Press my finger on the button here. Reinsert. Back to AT mode, now on the slave module. Alright, so let's get the serial monitor open again. Press that button here. Okay, and good, that comes up. Let's type in AT. Doesn't seem to work the first time, but try again. Great, now let's check the name of this. There we are. Right, and I might rename this, make it and S for slave. There. To confirm, there we are, good. Let's check the password to make sure it's the same as the master. It must be the same. Great, it's the same. Let's check the communication parameters to make it has to be the same too as the master. And yes, it's the same. Let's check the role now. It has to be slave role, which is a value of 0. And there it is, role 0. And let's check the connection mode, C mode, and it is 0, which is good. Let's bind it to the master We'll check the bindings. What is it bound to so far? It's bound to the master. Great. So that is ready to go. Alright. Now that both Bluetooth devices are configured, it's now time to test the connection. So to do this, we need to upload new sketches to both Arduino boards, one for the transmitter code and one for the receiver code. So what we have here is the code for the transmitter, and which is this code here. And so what does it do? So we're going to use software serial, so that way we don't have to use the hardware serial connections, a digital port 0 and 1. We can use any other digital pin. So here I've set the digital pin 2 to receive data from the Bluetooth, and Arduino pin number 3 to transmit data to the Bluetooth device. I'm setting a baud rate of 38,400 for the Bluetooth to communicate to another Bluetooth. Down here I create a variable called state, and state is a Boolean value, so therefore it only has two values, true and false. Here I basically create a object myBT, which is a software serial object, and I specify the pins for transmitting to the Bluetooth, and which is this one here, and receiving from Bluetooth, which is this one over here. So in my setup here I have pin mode, that basically tells the board that the pin for receive is an input and the pin to transmit is an output. Here, these two lines here, I specifically set a baud rate of 9,600 for the serial monitor, and a baud rate of 38,400 for the Bluetooth communication, which is down here. And then in the looping part, all I do is I basically send out, I write a message which is transmitted by Bluetooth, showing the state as an integer. That's what this does. It casts the Boolean value into an integer, so therefore true becomes a 1 and a false becomes a 0. So it transmits a number 0 or 1 to, via Bluetooth, and it also shows the value to the screen, delays 2 seconds, and then reverses the state. So true to false or false to true. Now let's see how this works. So I'll connect this up now. So here's my connection. And there we are. It should be blinking, trying to find a pair, but it can't yet. So now I'll go up to Tools, make sure the board is correct, make sure the COM is correct. Let's go and check this. Yes, it connects to COM5 here on this computer. And now let's upload the sketch. Compile and upload. Compiling. There it is. Now upload. Good, done. So now we'll open up the serial monitor. Okay, so as you can see, the transmitter is sending out a 0 and a 1. Okay, so that's the transmitting end of the communication process. Let's now focus on the receiving end. Here's my slave, my receiver. It's connected to the PC. Now it's time to upload the new code for the receiver, which is this file here, Bluetooth text RX. And so we have the same thing again, use software serial. I specify the same pins for receiving on Arduino and transmitting on Arduino, the same baud rate to communicate between Bluetooth devices. I create my software serial object here with the correct location of the pin for receive and transmit. And in the setup again, I have my input for that pin and output for that pin. I set my serial monitor to 9,600 again, and my baud rate for my Bluetooth device to communicate with the other Bluetooth device on the other board at the same value of 38,400. It has to be the same value. And in my loop, I basically say down here, if there is information available on my Bluetooth receiver, my slave, therefore show the value as an integer, and this is reading the Bluetooth buffer. And then I'm going to show you what happens if you don't get anything. Just uncomment these codes here, and it'll show you that maybe you're not getting anything. And you may want to change the delay too. So now to compile and upload. Compiling, uploading, done uploading. Go to the serial monitor. And let's see if we get any data coming out. So there's my receiver showing it is in sync with this, getting data. So let's look at the next one, and then 0, and the same thing. Great, all done. So now that you've achieved this, the next step is to, now that you've proven that your Bluetooth devices can communicate with each other, is to incorporate your Bluetooth transmitter and receiver into your project to build an RC transmitter and an RC receiver for your wireless application.